All right, this is for Chemistry CP, a debrief on the exam that you took on chemical reactions in March 2021. For the following chemical reactions, identify the type and balance the reaction. All right, well, I can look at this in pencil so that I can make changes as I build up my rap sheet. And doing this kind of quickly, I'm going to try putting 3 calciums here, but I can only go by 2s for the sodiums. So let me try putting a 2 here and a 6 there and a 3 here and see what that does. That means I have 6 sodiums on the left, 6 on the right, 3 sulfurs on the left, 3 sulfurs on the right, 2 irons on the left, 2 irons on the right, 6 chlorines on the left, 6 chlorines on the right. This equation is now balanced with coefficients 3, 2 yields 6, 1. And the type of reaction I would classify it as a double displacement. Number 2. Chlorine, aluminum chloride, fluorine, aluminum chloride seems to be a single displacement reaction, if you ask me. You are asking me. All right, well, single displacement. And to make this thing balanced, again, I have a 2 and a 3, so I'm going to try a 3 here, a 2 there, a 2 here, and a 3 there, and see how that goes. 6 chlorines on the left, 6 chlorines on the right, 2 aluminums on the left, 2 aluminums on the right, 6 chlorines on the left, 6 chlorines on the right. It's balanced. Number 3. This is a combustion reaction, a complete combustion, but we will just call it combustion. One of the more challenging type, I think, and I would do this by doing the oxygens last as I figure this stuff out. I see I have 5 carbons here, so I'm going to need at least a 5 there. We'll start with that. Okay, so 5 carbons to 5 carbons. 10 hydrogens means I would need a 5 here to give me those 10 hydrogens, but even number, odd number, even number, even number, so that's not going to work. I'm going to need at least a 2 here just to hope to have the numbers work out based on evens and odds. So that means I'm going to double this to a 10. Now I have 10 carbons on the left, 10 carbons on the right. I have 20 hydrogens on the left. So let's put a coefficient of 10 here. So I have 20 hydrogens on the right. Now I have 2 times 2 is 4, plus 2 is 6 oxygens on the left. Here I have 10 times 2 is 20, plus 10 times 1 is an additional 10. So 20 plus 10 is 30 oxygens on the right. So under my rap sheet for the oxygens, I have 30 on the right. I have 4 in the sugar, or whatever this is, hydrocarbon. So 4, and that means I need an additional 26 oxygens on the left. Half of 26 is 13. So let's make a coefficient of 13 and see how that goes. I have 10 carbons on the left, 10 carbons on the right. I have 20 hydrogens on the left. I have 20 hydrogens on the right. I have 4 plus 26 is 30 oxygens on the left. I have 20 plus 10 is 30 oxygens on the right. This is now a balanced chemical reaction. Number 4. Hydrogen phosphate and potassium hydroxide combine to create water and potassium phosphate. I would classify that as a double displacement. Reaction. And now to balance it, I'm going to leave the phosphates as a group. I would try a 3 here. No, looking at the hydrogens with the 2s. Well, I don't know. Let's try a 3 here and then go forward. So I have 3 potassiums on the left, 3 potassiums on the right. That's why I put the 3 here. I have 1 phosphate on the left, 1 phosphate on the right. Now I have 3 hydroxides and 3 hydrogens on the left. If I combine them, that could give me 3 water molecules on the right. Each of these 3 H's go with each of these 3 hydroxides to create 3 H2O water molecules. And therefore, I would do a coefficient of 1 for the remaining ones and see how this goes. So 3 hydrogens on the left plus 3 more hydrogens here, if you want to do it that way, is 6 hydrogens on the right. 1 phosphate on the left, 1 phosphate on the right. 3 potassium on the left, 3 potassium on the right. And if you like, 3 oxygens on the left, 3 oxygens on the right. Balance. Number 5. Tin plus hydrogen sulfuric acid, I suppose, yields hydrogen gas and tin 2, tin 1 sulfate. Suppose it's tin 1. All right, well, I would view this as a single displacement reaction. Single displacement. Because this one's not attached to anyone. And then to balance this, I see I need at least 2 sulfates here. So that means I need at least 4 hydrogens there. And then try that and see how it goes. 1 tin on the left, 1 tin on the right. 4 hydrogens on the left, 4 hydrogens on the right. 2 sulfate polyatomic anions on the left, 2 sulfate polyatomic anions on the right. It's balanced. Number 6. This would be decomposition. It's something breaking apart. Again, with the 3s and the 2s, I'm thinking I'll try a 2 here, a 3 there, a 4 here, and see what that does. 4 aluminums on the left, 4 aluminums on the right, 6 oxygens on the left, 6 oxygens on the right. It's balanced. Number 7. For the following sentence descriptions, write the correct chemical formulas and balance the reaction. Also identify the type of reaction. Aqueous ammonium perchlorate reacts with aqueous cobalt-3 dichromate to make aqueous cobalt-3 perchlorate and aqueous ammonium dichromate. All right, well, let's get into it. Ammonium is NH4. It's always a +1 charge, and I'm going to have to refer to my list of common ions to look up what is perchlorate. Perchlorate is ClO4 with a -1 charge, or 1- charge. ClO4. So ClO4, since ammonium, in case you didn't memorize it, ammonium is a 1+ charge, and perchlorate is a 1- charge. There's no need for parentheses, don't write them. Just one of each will do. NH4ClO4 reacts with +, aqueous cobalt-3 dichromate. Cobalt is CO. Cobalt-3 means it has a 3+ charge. Dichromate is a polyatomic ion with a 2- charge, Cr2O7. So I'm going to need parentheses. I will need 2 cobalts, then open parentheses, Cr2O7, close parentheses, subscript 3. So I've done my crisscross so that I have 3 groups of -2 charges to balance 2 of the +3 charged cobalts. All of this is aqueous, so in parentheses, AQ, to make, arrow pointing to the right. Aqueous cobalt-3 perchlorate. Well, perchlorate is a 1- charge. Cobalt 3 is the 3 plus charge. So for each cobalt, I'm going to need open parentheses, ClO4, close parentheses, subscript 3 to make that balance. And it's aqueous, so AQ in parentheses, plus ammonium dichromate. Ammonium is NH4, always with a 1 plus charge. Dichromate is with a 2 minus charge. So I'm going to need 2 ammoniums. So parentheses around the ammoniums, subscript 2. And now for the dichromate, I see I wrote Cr2O3. I should have written Cr2O7. So that's a typographical error or a human error, pilot error. Cr2O7 with a 2 minus charge. So here I write Cr2O7 and it's aqueous. So in parentheses, AQ, there's the skeleton equation. Now to balance it, I will start by saying I have 3 perchlorates there, only 1 here. I can only go by even numbers on the ammoniums. So if I put a 3 here, that's not going to work. I can double it and try a 6. That means I would have to put a 3 here. And now things are looking kind of hopeful, particularly if I put a 2 there and a 1 there. So let's see how that goes. 6 ammoniums on the left, 6 ammoniums on the right. 6 perchlorates on the left, 6 perchlorates on the right. 2 cobalts on the left, 2 cobalts on the right. 3 dichromates on the left, 3 dichromates on the right. This is now balanced. And finally, identifying the type of the reaction, I would classify this as a double displacement reaction. Next page. Number 8. Flammable, ethylene gas C2H4 burns with the help of diatomic oxygen gas to make gaseous carbon dioxide and water. Well, I would classify that as a combustion reaction. Ethylene, they said, is C2H4. Burns with the help of diatomic oxygen, so that's plus O2 in the gaseous state. By the way, little subscript here for the first reactant is also gaseous state. Burns with the help of diatomic oxygen gas to make, so that's an arrow pointing to the right, gaseous carbon dioxide, so CO2 subscript G for gas, and plus water, H2O presumed liquid, L. All right, now to balance this reaction, again, do the oxygens last. Looking at the hydrogens, I see they're all even. The oxygens, this has to be even. I have 4 hydrogens here, 2 carbons there. Let's try 2 for the carbons and 2 for the hydrogens. Now I have 2 carbons on the left, 2 carbons on the right, 4 hydrogens on the left, 4 hydrogens on the right. I currently have 2 oxygens on the left. On the right, I have 4 plus 2 is 6 oxygens on the right. So if I put a subscript or coefficient 3 in front of the oxygen gas reactant, everything should now be balanced. 2 carbons on the left, 2 carbons on the right, 4 hydrogens on the left, 4 hydrogens on the right, 6 oxygens on the left, 4 plus 2 is 6 oxygens on the right. I would classify this as a combustion reaction. Number 9. Copper metal reacts with aqueous iron 3 sulfate to create solid iron and solid copper 2 sulfate. Well, copper metal is just Cu, and that would be in the solid state, being a metal. Reacts with, that's a plus sign, aqueous iron 3 sulfate. So iron is Fe. Roman numeral 3 means it's a 3 plus charge. Sulfate is a polyatomic ion with a 2 minus charge. SO4 has a 2 minus charge. So I'm going to have to do crisscross and use 2 irons, and then open parentheses, SO4, close parentheses, subscript 3, so that I have 2 of the 3 plus irons to balance 3 of the 2 minus charged sulfate polyatomic anions. And that happens to be aqueous, so AQ. To create, that's an arrow pointing to the right. Solid iron, that's just Fe, and subscript S if you like, and, so plus sign, solid copper 2 sulfate. So copper is Cu, copper 2 is a 2 plus charge, sulfate is a 2 minus charge, so no need for parentheses, just write CuSO4 subscript S for solid. There's the skeleton chemical reaction, and now to balance it, well, I have 3 sulfates here, only 1 there, so I might want to start by putting a 3 over here, a 3 for the coppers, a 2 here, a 1 there, and see how it goes. 3 coppers on the left, 3 coppers on the right. Woo! 2 irons on the left, 2 irons on the right. 3 sulfates on the left, 3 sulfates on the right. This is now a balanced chemical reaction. I would classify this as a single displacement. Number 10, solid sodium bicarbonate breaks down into gaseous carbon dioxide, water, and sodium carbonate solid. All right, well, sodium bicarbonate. Bicarbonate, or hydrogen carbonate, is HCO3 with a 1 minus charge. Sodium, being a alkali metal, group 1A, group 1 element, is always a 1 plus charge. So no need for parentheses. I'm going to write Na for the sodium. And then the bicarbonate is HCO3. HCO3. Sodium bicarbonate, HCO3, breaks down. Well, that's just an arrow, no other reactant, into gaseous carbon dioxide. So that is CO2 subscript G for gaseous, plus water, H2O, presumed liquid, plus sodium carbonate, solid. Sodium is always 1 plus, and Na is sodium. Now, carbonate is CO3 with a 2 minus charge. So I'm going to need 2 sodiums to balance each carbonate. So Na2CO3, the CO3 again being carbonate, CO3 with a 2 minus charge, and since it's solid, subscript letter S. There's the skeleton equation. Now to balance it, well, I suppose I'll start with doubling the sodiums on the left. That gives me 2 sodiums on the left, 2 sodiums on the right, 2 carbonates on the left, 1 carbonate on the right. I'm a little troubled about the sodium bicarbonate and the sodium carbonate. So bicarbonate is HCO3 and carbonate is CO3. Well, I'm troubled because whatever I do to the sodiums, I'm also doing to the carbonates or bicarbonates. And here they're linked together this way. Here they're linked together that way. But some of these carbonates are breaking down to become carbon dioxide and water. So it shouldn't trouble me too much that they're linked here and linked there. What must be going on, though, I'm not sure. All right, let's just do this the hard way. At the moment, I have two hydrogens on the left. I have two hydrogens on the right. I have two carbons, because I'm not going to leave this as a carbonate now. I have two carbons on the left. I have 1, 2 carbons on the right. I have 6 oxygens on the left. I have 2 plus 1 is 3, plus 3 is 6 oxygens on the right. So that means it's balanced as written. Let's check one more time. 2 sodiums on the left, 2 sodiums on the right, 2 hydrogens on the left, 2 hydrogens on the right, 2 carbons on the left, 2 carbons on the right, 6 oxygens on the left, 2 plus 1 plus 3 equals 6 oxygens on the right. This is now a balanced chemical reaction. And I would classify this one as decomposition. Predict the products from the given reactants and balance the chemical reaction. Great. Number 11, silver phosphate. Silver is always going to be a 1 plus charge, and phosphate, not phosphide, is a polyatomic anion with a 3 minus charge. See, silver, monatomic cation, 1 plus charge. Phosphate, PO4 with a 3 minus charge. Phosphate, PO4 with a 3 minus charge. So I'm going to need 3 silvers for each phosphate. Ag3PO4 plus copper 2, all right, and chromate is Cr2O4 with a 2 minus charge. So if chromate is a 2 minus charge and copper 2 is a 2 plus charge, I don't need parentheses. I need just one of each of the two groupings there. So CrO4, CrO4, and I would predict that this is going to be a double displacement reaction. So we're going to have the silver and the copper basically switch places without changing the Roman numerals. So the copper, I don't, yeah, sure. I'll write the silver first. So silver is going to always be a 1 plus charge. The chromate is a 2 minus charge. So I'm going to need 2 silvers for every chromate plus the copper is going to continue to be a 2 plus charge, but the phosphate is a 3 minus charge. So I'm going to have to do crisscross and do a subscript 3 for the copper, open parentheses, PO4, close parentheses for the phosphate, subscript 2 to make them neutral. And of course, it's not enough to figure out what the products are going to be. We have to also balance it. I see the 2s, I see the 3s, and I'm thinking, let's try a coefficient 2 in front of the first reactant. That gives me 6 silvers on the left. I want 6 silvers on the right. So let's try a coefficient of 3 on the first product. Now I have 6 silvers on the left, 6 silvers on the right, 2 phosphate groups on the left, 2 phosphate groups on the right, 1 copper on the left, but 3 coppers on the right means I should try a coefficient of 3. I may have misspoken and called these things subscripts. So first reactant, coefficient of 2, first product, coefficient of 3, second reactant, I'm trying a coefficient of 3. That gives me 3 coppers on the left, 3 coppers on the right, 3 chromates on the left, 3 chromates on the right, and so this is now a balanced chemical reaction. Number 12, iron 3 hypochlorite and ammonium sulfide. So iron, being Fe with a 3 plus charge by the Roman numerals, combines with hypochlorite. Hypochlorite is ClO with a -1 charge. I'm going to need 3 of those in this situation. So open parentheses, ClO, close parentheses, subscript 3, so that I have 3 -1 charges to balance my 1 +3 charge. Combines with ammonium, which is always a 1 plus charge. NH4 is a 1 plus charge. Now sulfide is sulfur. It's not sulfite, it's not sulfate, it's sulfur. And so on the periodic table, if you need to check, sulfur is a 2 minus charge like oxygen. And since ammonium is always a 1 plus, I need 2 of these ammoniums to balance that single sulfur ion. So NH4 in parentheses, subscript 2 to go with the 1 sulfur. I would predict that this is going to be another double displacement reaction to become iron. Now it's still going to stay as iron 3, hooking up now with sulfur. Sulfur is -2, so we have to do crisscross. Fe subscript 2, S subscript 3, so that I have 2 +3 charged irons for every 3 -2 charged sulfurs. Plus ammonium, always write the positive cation first, with this 1 plus charge, is now going to hook up with hypochlorite. And in case you can't tell by looking at this, you could look it up and confirm that hypochlorite is a 1 minus charge. So ClO, no subscripts. All right, so there's my prediction. Now to balance this, I see I have 2 ammoniums on the left, I have 1 sulfur on the left, 3 sulfurs on the right. So how about I try a 3 here to get the sulfurs balanced, and that means a 6 here to get the ammoniums balanced, and then keep going from there. A 2 in front of this, and then see what happens. This being the first reactant. 2 irons on the left, 2 irons on the right. 6 hypochlorites on the left, 6 hypochlorites on the right. 6 ammoniums on the left, 6 ammoniums on the right. 3 sulfurs on the left, 3 sulfurs on the right. This is now a balanced chemical reaction. Number 13. Zinc metal and aluminum chloride would be a single displacement reaction. Zinc is one of those always 2 plus charged monatomic cations. Zinc is always a 2 plus charge, and it's solid. Combines with aluminum. Aluminum is always going to be a 3 plus charge. Chlorine is always going to be a 1 minus charge. So I'm going to need 3 chlorines for each aluminum. Being single displacement, this is going to become zinc chloride and aluminum. And this zinc always being a 2 plus charge, I better have a subscript 2 for the chlorines, or else I will have made a mistake. Yeah, yet another one. Okay, so next step is to balance it with the coefficients. I see the 3 and the 2 for the chlorines, so I'll try a 2 here, a 3 there, a 2 there, and a 3 here, and see what happens. 3 zincs on the left, 3 zincs on the right. 2 aluminums on the left, 2 aluminums on the right. 6 chlorines on the left, 6 chlorines on the right. This is balanced chemical reaction. Number 14. Cobalt 3 arsenate and lead 4 permanganate. Cobalt is CO. The Roman numeral 3 means the 3 plus charge. Arsenate is a polyatomic anion, and it has a 3 minus charge. ASO4 with a 3 minus charge. because cobalt is a 3+ charge in this case, I don't need parentheses. I need just one of each of these groups. And again, arsenate is ASO4. All right, so there's cobalt-3 arsenate. It's going to combine with lead-4. Lead is Pb. Permanganate is another polyatomic anion. Permanganate is MnO4 with a -1 charge, or 1- charge. Well, lead-4, Roman numeral, means it's 4+. So I'm going to need 4 of the permanganates. And the permanganate, again, is MnO4, in parentheses, subscript 4, so that I have 4 of these -1 charge permanganates to balance the 1 for positive charged lead. I would predict that this is going to be a double displacement reaction. So it's going to switch into cobalt still 3 permanganate. And so open parentheses, MnO4, close parentheses, subscript 3. Since permanganate is a 1- charge and the cobalt is a Roman numeral 3, I need 3 permanganates for each cobalt, plus lead, and it's still going to be lead Roman numeral 4, arsenate. Well, arsenate, you can see, must have a 3- charge, and the lead has a 4+ charge. So by crisscross, I will need 3 leads for every 4 arsenates. 3 times these +4 charged leads will balance 4 of these -3 charged arsenates. So there's my skeleton equation. And now to balance it, I would try, since I have a 4 here and a 3 there, how about if I try a 3 here and a 4 there, and then go up from there. So I have 1 cobalt on the left, 4 on the right, so let's bump this up to 4. Now I have 4 cobalts on the left, 4 cobalts on the right, 4 arsenates on the left. I have 4 arsenates on the right. I have 3 leads on the left. I have 3 leads on the right. I have 12 permanganates on the left. I have 12 permanganates on the right. This is now a balanced chemical reaction. Number 15. Phenyl C6H6O undergoes complete combustion. So C6H6O, combustion means combines with diatomic gaseous oxygen. And complete combustion means the products are carbon dioxide gas and water. And this would be a blue flame if you wanted to look into a gas flame. To balance this, do the oxygens last. I will start by observing I can have an odd number of oxygens on both sides. So I'll go after the carbons first. 6 carbons on the left, let's make it 6 carbons on the right. 6 hydrogens on the left, let's make them with a coefficient of 3 in front of the water, 6 hydrogens on the right. Now I currently have 3 oxygens on the left. On the right, I have 12 plus 3 is 15 oxygens on the right. So I want 15 oxygens on the left. Let's leave one of them here. And so now I want 14 more oxygens. 14 divided by 2 is 7. So I try a coefficient of 7 in front of the oxygen gas and do a final check. 6 carbons on the left, 6 carbons on the right. 6 hydrogens on the left, 6 hydrogens on the right. 14 plus 1 is 15 oxygens on the left. 12 plus 3 is 15 oxygens on the right. This concludes the debrief on this exam.